Hello. First of all, a little disclaimer. YouTube recently blocks some of my streams, some of my nails, and I don't know the reason, and actually I don't want to know the reason why it happens, and it slightly disappoints me a little bit. I know I said that I'll share every day new nail, but it breaks this timeline, and so I'll share it how it can be implemented, and then I at least will try to create 32 nails. It's a round number, 32, you know. Yep, and then I'll think how to continue it, maybe trying to find out another ways for sharing it. So then let's start. Today we'll start a 3 nails session about unexisted problem, about imaginary problem. Why I call this problem imaginary? So if it was a real problem, then there would be a solution for it, then there would be a huge approach, different talks about it, and so on and so forth. But while we are not seeing a lot of mention of this problem in development process, so that's looks like it's not a real problem. I talk about Stack Overflow. Yeah, you know, Java and of course JavaScript can be fallen in a Stack Overflow. Even Haskell also can be fallen in Stack Overflow, but a little bit harder, to be honest, yeah? But Java, it's quite easy to break into Stack Overflow, and even such IDEs as IntelliJ IDEA highlight your recursive methods of class and put your attention on. So, are you sure? Are you sure you are trying to use recursion? It's dangerous. It's terrible. Do not do it, and so on and so forth. So they're afraid about recursion at all. But here in Clojure we're using recursion a lot. But let me explain you in today's nail a little bit deeper about it. First of all, we are trying to implement a function which returns amount of sum of numbers from 0 up to given value. We call it foo, and we will use accumulator, and we first we will call the recursive function foo by its name directly in a naive way, and yep, of course, calling it on a little arguments, for example on 10 will return 55, but calling it on some great argument fire Stack Overflow. Yeah, you see. And Clojure has built-in a way for avoiding it. So just use recur keyword instead of calling a function by its name itself. Let's reval it and call on big argument. And yep, of course, it works without Stack Overflow. And now I'll I'll have to ask you, did you know the actual difference between such abbreviations TCO, TRO, I mean tail recursion, tail call, terminal call? What does it mean, tail call optimization, tail recursion optimization, and so on and so forth? I'd suggest you to stop the video and think about it a little bit, and later I'll explain you. Oh, so and then we'll continue. But in order to continue, I'd suggest you to go to my own language. It's called LeeScript. Here you see its REPL. It's also a Lisp family language, but here we will clearly see the stack traces of tail call and not tail call cases. What do I mean? For example, let's implement the same function foo, which in bar, 2 implementations of the function which returns the sum of natural numbers from 0 up to given value. First implementation will be tail recursive with accumulator, and second implementation will be not tail recursive and without accumulator. I think it's quite obvious things, and I hope you know what is tail recursive implementation of, for example, factorial, and no tail recursive implementation, and how they are different from each other, what accumulator actually is, and so on and so forth. Yep, and let's try to call it on little values. For example, foo from 10. Oh, it returns 55, yep. And bar from 10 also returns 55. But trying to call foo from 10,000. Yep, it returns value. And bar from 10,000. It returns, it's a Russian words Stack Overflow. Yep, so let's do a little deeper and call stack trace of non-tail call implementation and tail call implementation. Stack trace of call function bar from argument 10. Yeah, maybe let's make font a little bit smaller. Yeah, you see, it's a triangle. We go into the stack deeper and deeper and deeper and deeper and deeper and deeper. So it moves to the right side, all the calls. And then when we feed the 34th level of stack deepness, then we find out the final solution, and we will return back from the stack and return value of 55. Yep. But if we call stack trace of function foo on argument 10, it's linear, it's flat, and the maximum stack deepness is 5. First of all, first call is stack level 1, then level 2, 3, up arguments 4, blah blah blah. Then condition check is stack level 5, and then also we return back on level 2, and then back up to level 5, and so on. So the maximum stack length is not so deep. Also, if we trace function foo not from argument 10, but bigger argument, let's do it on argument 12 or 20. The same. It's just longer, but the same pattern, it's flat. So I have built in tail call optimization here in my language, and it works automatically. I have no explicitly set such words as recur and so on and so forth. But it's actually not only tail recursion optimization, it's actually a tail call optimization. What do I mean? Tail recursion is the fact when function recursively calls itself with different arguments values. But tail call is a much wider term. For example, we can have mutual recursion. We can implement two functions, is even and is odd, and they will call each other is even function if argument is 0 then true. Else we'll call is odd on decremented argument, and is odd if argument is 0 then false. Otherwise we'll call is even on decremented argument. And also let's call stack trace, for example, is even on argument 10. The same pattern, flat linear pattern. But it's not a tail recursion at all. It's a tail call. And even if we call is even on 1 million, it's true. Even more, we do not have a recursion at all to be in tail call case. What do I mean? For example, these three functions, hello, my, and dear, of one argument each. Function hello concatenates word hello to its argument. Function my calls function hello on changed argument, which is actually concatenated word my to its value. And function dear calls function my. So it's a sequential call of each function. Hello returns a slightly altered argument. Function my calls function hello on altered argument, and function dear calls function my on altered argument. There is no recursion here. Neither linear, neither primitive, neither mutual at all. But if we will call dear boy, it returns hello my dear boy. Maybe I'll show you in a big font. Yeah, dear boy, hello my dear boy. And let's go back to small font and call trace on this call on dear boy. The same linear pattern. We have no triangles here also, but it's not a recursive calls at all. That's my point. So tail call, it's a slightly wider thing than the tail recursion. So let's go back to the Clojure. And here we can see that Clojure has built-in tail recursion optimization, but not tail call at all. It will not optimize mutual recursion. It will fit in a Stack Overflow and so on and so forth. But what we can do in order to make things better. For example, for all the tail calls, we can use so-called trampolines. It's a well-known pattern. When the function, instead of returning a value, it returns either lambda, either some structure, but not the exactly evaluated result, but some special object, which we can alter in naive loop. So we, instead of recursion calls, we will call loop function on its argument until it will not a trampoline method. So you can go deep into these macros and copy paste them from the screen. But how they works? For example, in user interface we can just add simple word tr, it's a macro trampoline, before foo, naive call of tail call of function foo. And then on evaluation step we have to wrap it in eval trampoline. So let's play it. Yep. And here again, it's no Stack Overflow here, even if we do not call recurse special keyword directly. But it can be used with mutual recursion too. For example, let's play with naive mutual recursion. The same function is even isod without trampoline. Yep. Okay, Stack Overflow, of course, is predictable. Because Clojure doesn't optimize the mutual recursion call, and everywhere. Anyway, we have no recurse special keyword here. But if we wrap it in tr, just like here, we can use it, and is even 1 million is true. Yep, that's actually maybe all for this nail, but only last thing. I heard a legend that Richike may implement the tail call optimization in Clojure implementation on Java, but he didn't do it, and the argument was in this case it's hard to analyze the stack traces of function calls. So we will not have tail call optimization in order to look in the stack traces. I'm not sure that it's a sufficient argument, but anyway, we have that we have. And the Python has the same approach, and Guido van Rossum has the same argument. I will not implement tail call optimization built in my language, because we have to look into the stack traces. So that's up for today's nail. See you next nail, where we will analyze so-called custom stack evaluation and trying to avoid Stack Overflow not on tail call cases but on any recursion calls. See you.